Hey y'all, it's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic is talking about absolute maximums or minimums or relative maximum or minimums. Now, absolute means it cannot possibly be any higher or cannot possibly be any lower. Relative maximum or minimum means that within an interval you have a maximum. Remember, that's within the interval on the x-axis, or on the interval on the x-axis you have a minimum, so that there's a low point in that interval on your graph. So let's look at what I'm talking about. Here's some graphs. We should be sort of familiar with them, and I want you to notice there is no absolute maximum or minimum, because all five of these graphs go on forever and ever and ever, and we never get too high, and we never stop going up, and we never stop going down. So there is no absolute maximum, and there is no absolute minimum. So let's cross that out. There is none. Okay? None. But what we do have is some relative maximum and minimums. So let's look at some of these maybe a little bit closer. The linear has no relative maximum or minimums, but a cubic does. One here and one here. So within the interval, say, of -1 to +1, I have a relative maximum at about 1.5. That means that's where the y value is. And I have a relative minimum at about y equaling 1/2. Now, go over here and look at the quintic. I have two relative maximums, and I have two relative minimums on the interval of -3 up to +2. Now, let's look at this lovely nonic. It doesn't have any absolute maximum or minimum because it goes on forever in both directions. But I do have some racks, absolute, relative maximums, and I have some relative minimums. And we can narrow those down. Now, what I do want to do is I want to look at a table of values. All right? A table of values. So let's look at a table of values. Let's move out. Okay. So let's turn this on. I have a table of values. Okay. I typed in this equation here. Obviously, it is a negative coefficient with an odd degree, right? So I know that this is going in a upper left to lower right. Okay, let's look at, we're going to start at -5. Let's look at our table of values. Okay, see, I'm coming in real high. As I go down and through, we're getting closer and closer. Oh, okay, here's a 0. Okay, that's a 0 of the function. Oh, another 0, and all of a sudden starts dipping back down. Now, this right here does not mean my graph flattened out. My graph did not flatten out. And I can show you that for sure because I graphed it at Desmos. So here's the graph. Here's the graph at Desmos. All right. It's the same graph. As you can see, we're coming in high. We dip down low. We flatten out. We come back and dip down. So here's the 0 at 1 that we saw on the table of values. Here's the 0 at 0, and here is the 0 at -1. But as you can see, I have a relative minimum, okay, and it gives us the ordered pair, and then I have a relative maximum. And Desmos is a wonderful place to go to look at things. So with that said, I wanted you just to look at that graph, and we'll probably go play with Desmos in class. Right, now, let's talk about a couple other graphs we have. Okay, let's talk about even degree. caution, this is an even degree. They do have absolute maximums and minimums, and they also have relative maximum and minimums. Okay? A quadratic that is a positive leading coefficient has a absolute minimum. It has a low point that you cannot go any lower. Okay? Here's a low point that I cannot go any lower. That's where my range actually starts. I do have a relative maximum here and another relative minimum here. In the sextic, we have again, here is our absolute minimum, relative maximum, relative minimum, relative maximum, relative minimum. Looking at a negative coefficient, okay, at a negative coefficient, I have an absolute maximum going to happen because that's as far as my graph can go because it's upside down. Remember, it's like an upside down W or U, okay? And just like it, I'm going to have a absolute maximum at any point on an even degree negative coefficient. But I can also have lots of relative ones. If there's any questions about this, we need to go back and look at that table of values a little bit better. So let's go back and look at that table of values. All right? I'm going to show you how we can get in here and find those relatives, maximums and minimums. So we're going to go to table of values. We're going to hit enter again. We're going to step by smaller amounts. Okay, we were taking a full step. Let's look at a tenth of a step and see what happens to my table of values. Okay, there's my 0. Okay, and as I go down and through, I can see, oh, okay, I'm starting to come back up. Okay, then I go back down and through, and I hit my maximum in here, and I come back down, and I continue to start going back down through the graph. Remember on Desmos, that looked like this, and we can go back in, and we can see that I went down, came back up, went up, came back down. Now, for those of you that get confused about these fractions that we have here, like this one here, let's toggle over to it, and let's tell it, see this button right here? I can tell it to look like a decimal right there. So I can compare my decimals as to where is my largest decimal. If you have any questions, write them down, come to class. I'll be happy to answer them during tutoring, and I hope you have a good day. Bye.